So we have Caden and Jada that are leaving from the same restaurant at the same time and traveling in opposite directions. So if Caden travels 10 miles per hour and Jaden travels 13 miles per hour, how long until they are 184 miles apart? So what we have here is a distance equals rate times time problem. So distance equals rate times time. But the thing is, we have two different trips because we basically have Caden's trip and we have Jada's trip. So what we're going to do is we're going to make a table with two different rows for trips. So we'll have Caden's trip up on top and Jada's trip below. So we'll fill it in Caden's distance, Caden's rate, Caden's time, and so forth with Jada. So we have Caden travels 10 miles per hour. We'll put that here. Jada travels 13 miles per hour. How long until they are 184 miles apart? So we know that their time is going to be the same because however they're going, they might start right here. One of them might travel further, one might only travel a little bit, but we're wondering just at what point do they reach 184 miles, okay? And so their time is going to be the same. We still don't know the time, so we're just going to put T for time. Now the distance is a little bit trickier. We can't just put 184 miles because as you can see here, it's 184 miles total. And so what we're going to do is we're just going to put distance for one of them, and it's just some distance, and the other one is going to be 184, which is our total amount, minus Caden's distance. So basically this is what's left over. Okay, so this is a way when you don't know, when there's two parts, they're not divided evenly. This is a way to set them up with variables. And it doesn't matter which has the D and which has the 184 minus D because it'll work out. For example, if D equaled 13, D would just be the 13, and then this would be 184 minus 13 or 171. So it works itself out. Okay, so we have our table all set up. So what we're going to do is we're actually going to use this distance equals rate times time formula to set it up. Now there's a couple of different ways we could do it, but I'm looking, and since we just have T isolated, I'm thinking let's isolate T in this equation so we can see what we would get. So if we have T, those R's canceled, equals D over R, that gives us a way to still use this equation. And so we're going to do that with both of these. So Caden will have T equals D over 10. So using that same formula. For Jada's, we'll have T equals 184 minus D because that's Jada's distance, and then over 13. So I'm just using this table to set up these two equations. Now we have two equations and two missing variables. And so what we're doing now is we can use the system of equations to solve this. You can choose the elimination method, or it's also called addition, the substitution method, and in this case I'm going to use substitution. Since we know T equals D over 10 and T equals 184 minus D over 13, we also know that this equals this, since T is equal to both of them. So that's what we're going to do, is we're going to say, okay, D over 10 equals 184 minus D over 13. And then at this point, notice we have an equation and only one missing variable, so we can solve this. Whenever you have a fraction equal to a fraction like this, you can use cross multiply method. And there's other methods you could use, but this is the way I think is the easiest. So we multiply 13 times D, and then we're going to set that equal to 10 times the whole 184 minus D. So let's multiply that through. We still have 13D on the left equals 1840 minus 10D. Now we're just going to solve it. So get our D's on the same side. Those cancel, so we get 23D equals 1840. And then we want to keep solving for D, so we can divide by 23 on both sides. So 1840 divided by 23, we're going to get D equals 80. So our distance is 80. Is that the answer they're looking for though? But it's not quite. It says how long until they are 184 miles apart. So they're looking for the time. So what can we do with this 80? Well, we can substitute it back into one of these equations. It doesn't matter which one. Since this top one is more simple, I'm going to use that one. So we have T equals D, or 80 divided by 10. So the time here then would just be 8 hours. So in 8 hours, they are 185 or 84 miles apart. Hopefully that helped. If not, reach out and I'm happy to help.